Quantum number. This video is primarily for those students who are in honors chemistry, just to get that out of the way. Okay, there are 4 types of quantum numbers. The first one is the principal quantum number. This quantum number is used to represent the energy level. So this would include, the 1, the 2, the 3 in front of the S, P, or D. The next quantum number is the angular momentum quantum number. And this is used to represent the orbital shape. It describes the sublevel type. So it gives a number to if it's an S, a P, or a D. To really expand on that, if it's an S, we're showing an S orbital, it'd be represented by a 0. If we're showing a P, it's represented by a 1, and a D is represented by a 2. Moving on here, we have our next quantum number, which is the magnetic quantum number. So this is the orientation of the orbital in space. It's talking about specifically which one it really is. So it ranges from -1 to -L to +L. So I'm just going to kind of draw out this chart for this one here and kind of tying in with the angular momentum one to make sense, because it just sounds like I'm saying a bunch of words right now. So if we draw our table here, we have our sublevel types. So an S would be a 0, a P would be a 1, a D would be a 2, and an F would be a 3. Okay, and we go from +L to -L. So this is just saying the orientation in space. So this one's always going to be 0, so this will be our third quantum number when we represent it. This one's going to go always +1, 0, or -1. That kind of just depends what slot it's in. It'll make more sense when I do an example. This one goes +2, +1, 0, -1, -2, and this one goes +3, +2, +1, 0. Let me get myself a little bit more space here. -1, -2, -3. So just keep this chart in mind when we do our examples. So I'm just going to pull this chart up here while we do our first example. So, I have to mention the last orbital number actually. Sorry, mea culpa. Let's see if we can go back here. So our last orbital number is the spin quantum. So this is as specific as we can get. So this is just saying, what's its spin? So this is either going to be a 1/2 that is positive, or it's going to be a -1/2. So if it's a positive 1/2 like that, this means that it's going to be an up arrow, and that's if we're using our orbital diagrams there, and the negative means that it's going to be a down arrow. Okay. Let's just try some examples, because I'm hoping that will make a lot more sense when we do one. So let's say if I were to ask you to do the orbital numbers of, let's pick a really good one here, nitrogen. So write orbital quantum numbers. Sorry, I don't know why I said orbital numbers there. Write quantum numbers for nitrogen. And this is commonly what you would have to do on a test. So the first thing that we want to do when starting this is first making our electron configuration. So nitrogen has an atomic number of 7. So we just go 1s2, 2s2, 2p3. Okay. From there, I typically like to do an orbital diagram. So an S, I know is one block. Another S, I know is another block. P, I know is a 3 block. So 1, 2, 3. Then I'll draw my orbital diagram there. and then I can start writing my quantum numbers. Okay? So our first one we said is our sublevel. So we're going to do our first quantum number. So this one will have a total of 7 quantum numbers, right? Because we have 7 electrons. So our first quantum number, we're going to start with, like we said, it's our principal quantum number. So this is just talking about our energy level. So for our first quantum number, it has an energy level of 1. Okay, pretty simple. We see the 1 there, 1 there. The next one, sorry, it is our angular momentum. So this is just saying if an S, P, D, or an F. That's a really bad F now that I'm looking at it. But, so for an S, we know that S is going to be 0. Okay. Then what's our next one? Our magnetic quantum. So that's just saying where it ranks. So our first one, it's an up arrow. So S's are automatically going to be 0. So we can just automatically write a 0 there. I'm going to put it in a different color, actually. It's going to be a 0 there. And then for our last one, it's talking about the spin. So we're doing our first up arrow first. So it's always going to be a 1/2. Okay, so that's how we would do that's our first quantum number. Okay, let's do our second quantum number now. So we start with the energy level again, so we're still on the 1s2, so this is our second electron in it now. So we know it's going to be a 1 there. Then our second one, since we know it's an S, we're still on the S. It's going to be another 0 again. Now we know S's are automatically always 0, 2 for the third number in that quantum number. And for our last one, so this one's the down arrow one, so that means this is going to be our negative 1/2. Okay? Let's move on. So now let's go into our 2s2s. So now we know that I'm going to change colors here to make it a little bit easier to see. This one, it starts with I'm going to write it in order actually. This one, now we have a second energy level. It's still an S, so it's going to be a 0. And it's still going to be a 0 for the orientation in space. And it's our first up arrow, so it's going to be a 1/2. Okay? Next one, our second electron there, so this is our fourth total electron. It's still in the second energy level. And S is a 0. And S's are automatically in orientation in space a 0, 2. And it's our second electron, so it's going to be a negative 1/2. So I'm just going to write 1, 2, 3, 4. So I'm going to write on the side here now. Now we're moving on to our 2p3. So this is where it becomes a little bit more difficult. The first 1s2 and 2s2, those are pretty much just second nature. It's always going to be like that. Okay, so the first electron of our 2p3, so we know the energy, that's simple. I'm going to change colors again. That one's going to be simple, so that's always going to be a 2, that's going to be a 2 there. And then our second one there, it's a p, so this one's going to be a 1 this time. But since it's our first electron there, I'm going to zoom in here, mark this up. So this is always going to be the +1. So if it's in here, this is going to be a +1. We're going to just represent it as a 1. This will be our 0, and this will be our -1. So kind of want to touch on that a little bit further since now that we've reached it. S, it's just always going to be a 0 there. For the P's, it's always going to be a +1 if it's in this first, I guess, block there. I keep representing as blocks. That's just how mine works of understanding it. This one's always going to be a 0, and this one's always going to be a -1, so I'm just going to represent that as S. This is a P. And then for our D, 1, 2, 3, 4, 5. It would start with +2, +1, 0, -1, -2. So just kind of keep that in mind. Going back to our nitrogen here. So we were starting with our first one here. We knew it was a P. Then we knew that our first one here is in the first one, so it's a 1 again. And it's the first electron in there, so it's a 1/2. Let's go to our next one here. It is our 2p2, so it's in our second energy level. It is a P. N is in our 0 spot because it's this electron here. And it's a forward spinning, so it would be 1/2. And then finally, our last quantum number is an energy level of 2. It's our p sublevel, and it's on our -1 spot. And it's a 1/2 positive spin. I'm going to do some more examples in the next video, just 2 more. But have a great day, and I hope this video really helped you out. Thank you.